Hi everyone. Today we're going to see a biweekly contest 149 problem, the third problem. There is actually a version 1 of this problem, so I suggest you to see that problem. And let's see the problem description. And we're given an integer even time and also an array of integers start time and end time. Both have lengths n. And the start time and end time represent a meeting, and the start time at I and end time at I represent a meeting that occurs during that time, and all meetings falls between the t is equal to 0 and t even time, the given integer. And we can reschedule at most one meeting, and whenever we are rescheduling we have to keep their duration, and it should not go beyond the event time. And we have to return the maximum amount of free time possible after rearranging the meeting. And there are a few things that we should note, and that is a meeting cannot be rescheduled to a time outside the event, and they should remain non-overlapping. And in this version, it is valid for the relative ordering of the meeting to change after rescheduling one meeting. So we can place it anywhere in the given interval. It should be free space. So the order doesn't matter. Let's see with the example. We have event time 5 and we have two meetings, and the first meeting starts at 1 and ends at 2. The second one starts at 3 and ends at 5. And the interval of our meeting should fall between 0 up to 5, and we can actually move this meeting to the right, and that would give us two free space. And the maximum free time we can get in this problem is 2 units. And let's see the problem further with different example. And we have 4 meeting, and our event time is 10. And if we want to solve the problem, we can slide the meeting to the right. But since the order is not going to be a problem, we can actually move it all the way to 8. That would give us 6 units of time. And yeah, that's the maximum answer we could get in this problem. You can try placing the others. So this one is going to be the maximum. And one thing that we need to note is that we can only move one meeting. And that's very important, because since we can move only one meeting, we check for each meeting to find an available time slot to reschedule it. And we have the first meeting is starts at 0 and ends at 1. So we can place it in these free spaces because it is possible. Uh, let's see that with the second meeting, and we can bring it to the left or bring it to the right. That's the possible places we can place this meeting, but the order doesn't matter, right? And if we do that, if we slide the meeting to either left or right, that will give a free space of the left free space and right free space combined. So this will give us a total available free space combining both the left and right free spaces. And what do I mean by that? Then when we slide it to the right, that will give us both of these summed up together. But we can do better, right? Because the order doesn't matter. And if you see this space, it's free, we can place this meeting there. And whenever we do such kind of arrangement, it will this will provide the total available free space by combining the left and right free spaces along with the space previously occupied by the current meeting. So the second meeting occupied 1 unit of time starting at 3 and instead 4. Now we moved it all the way to 8, so it's also going to be considered as free space. And as from this we can see that for each meeting there are two possible actions. We can completely reposition the meeting, move it entirely to either the right or the left free spaces, and this doesn't include actually the adjacent free spaces to that current meeting. Or we can either partially shift the meeting, that is, move it to the leftmost part of the left free space or the rightmost part of the right free space. And this option is always possible as there is always going to be enough room. And even if we don't have space between them, like this one, we're going to be placing these as zero free spaces. So it doesn't matter. We assume that we already shifted it to the right. And so this is how we are going to solve the problem. First, we're going to store the available free spaces we have. And the free spaces we have is here 2, here 3, and here 1. Actually, we do have other free spaces, but we cannot go beyond the event time, which is 10. And for each meeting, we check the left or right free spaces from stored available spaces to determine where we can place it. And we also keep the track of maximum result. So let's see that by visualizing it. So for the first meeting, we can place it somewhere which is free, and it should not be adjacent free spaces. And whenever we have such kind of arrangement, as I said before, is going to be the free space we have from the left, this free space we have from the right, summed up with the space occupied by that meeting. And the meeting occupied 1 unit, and we had 2 free space from the right and 0 free space from the left. When we sum them up together, it's going to give us 3. And our answer was previously 0, and we take maximum of that. And we can also shift it to the right? And as we said, this is always possible. And that will give us the left free space summed up with the right free space. And we had 2 free space from the right and 0 free space from the left. When we sum them up together, it's going to give us 2. Actually, the maximum of these 2 is going to be 3. And we move on to the next meeting. We can do those 2 operations on this because we can place these here. But as you can see, but how are we going to know where we should place this? Either we can place it or not, right? But how are we going to know that? So we're going to check every free space we have to the left and every free space we have to the right. And we're going to pick a maximum of them. And if we have a maximum that could contain this meeting, so we can say that we can place it there. So from left, not including the adjacent free spaces, we have 0 free space. From the right, we have 1 free space. And since we have 1 free space from the right, we can place it there. But yeah, actually, we can do this as well. And we can either slide it to the left or right. And if we slide it to the left, that will give us 5 free spaces here. And if we move it all the way to 8, that would give us 6 free spaces. And we've talked how to do that we have to pick every free space from the right, pick every free space from the left, and we see if we can place in any position. And in this case, we can do, we can place it in the 8, and we do the same thing for all of them, keep tracking of the maximum. This is how we're going to do it. But the problem is that whenever we are trying to find all the free spaces from the right, it's going to be similar to brute force, right? It's going to be n squared, because every time for a single meeting, we're checking every free space to the right and every free space to the left. But that's not actually how we are going to do this. We're going to keep track of the maximum from the right and the maximum from the left, since we know that it can, if it cannot be placed in the maximum free spaces, it can't be placed anywhere, right? For that case, we only keep track of the maximum from the right, the maximum free space from the left. So maybe this is going to be clear when we code it up. Let's do that. So let's just start, and our answer is going to be 0, and we are going to return that. And we are going to have spaces. This shows the free space, and we start by the beginning start time. So any free space we have before the start time is going to be represented by this start time, and we start from, we are going to iterate over all the meetings, and we should leave the one behind because we already added here. And we are going to add the spaces we have into the spaces, and we are going to do that start time at the current position minus in the time at the previous position. So this will give us every free space we have, but we only left with one free space at the end. And we can do that by saying it's actually event time minus in the time, which is at the last. So we have all the free spaces, and as we said, we're going to keep the track from the left and from the right, right? So we say right maximum, and this is going to be for all the spaces, going to be 0 in the beginning, and starting from the back, spaces -2 -1, and this actually shows that we're coming from the end to 0, and we're going to decrement each step by 1. And the reason we left 1 behind is that because we are not considering the adjacent free spaces. That's the reason. And we say right maximum at current position is going to be maximum of right maximum before that right maximum, and the spaces before that as well. And it's going to be maximum of this. And now it is the time when we check for every events or meeting where we can place them. And we say our left maximum is going to be starting from 0. And we say for ein range, we're going to iterate over the meetings. Actually, we're going to iterate over the spaces because it's going to be the same. And we're going to start at 1 and length of spaces. And we calculate the current meeting is going to be start time, because we are starting from 1 and we're iterating over the spaces. That's why we are doing -1, and in the time -1. So this will give us the length of that current meeting, and we will check if the current meeting could be in one of the left maximum or right maximum at I. So this will tell us, can we place this meeting anywhere to the right or to the left? And if we can do that, the answer is going to be maximum of the current meeting summed up with the spaces before that and spaces after the current meeting, and it's going to be maximum of that or the previous answer we got. And as I said, this is always going to be possible. This is the maximum of current not current meeting spaces I -1 plus spaces I. This is when we slide the meeting to either to the right or to the left, or the answer. And we should not forget that we have to update our left maximum. So our left maximum is going to be maximum of left maximum or spaces before that. And we are going to return the answer. And let's check that. And as you can see, it worked. Thank you for watching, and hit the like button if you liked it. Thank you.